microscope. In order to understand phenomenon of resolution, we must try to understand how the image is formed by the microscope. If the light is passed through a small slit, it gets diffracted. The diffraction results in the formation of dark and bright spots. It should be noted that as the width of the slit decreases, diffraction of light increases. Now the question is, how does diffraction affect ability to see small objects? Let's consider an example where a slit diffracts light and produces a diffraction pattern on the screen. If we place a convex lens in front of slit, then the image of the slit can be seen on the screen instead of diffraction pattern. So what's happening here? Let's see. The slit diffracts the light, the diffracted light is collected by the convex lens, and the lens focuses the diffracted light on one point, resulting in an interference pattern, which ultimately forms an image. Now here's the thing, if the width of the slit is very less, then the diffraction pattern will be huge. Look at the size of central maxima over here. In this case, the lens fails to collect the diffraction pattern. If the lens fails to collect the diffraction pattern, the image obtained is blurred. A similar phenomenon happens when we try to see small objects with a microscope. As the object size gets smaller and smaller, the diffraction increases. This is because all the information regarding the tiny object that you see through a microscope lies in its diffraction pattern. As the object gets smaller and smaller, the diffraction pattern increases and the objective fails to collect the diffraction pattern. This problem is known as diffraction limitation of light microscope, and it is given by the following equation. The diffraction phenomenon also limits the ability of microscope to see two closely spaced objects. The ability to distinguish between two closely spaced